Hello everyone. In this video, I'm going to show you how to create and use SSH keys for authentication and how to manage said keys with the amazing tool Keychain. If you use SSH Agent, you have to deal with loading your keys per shell login. With Keychain, you only load your keys per reboot. This is just one of the many benefits of Keychain. Let's jump right in. The most basic way of logging into a server is with the username and password. After initiating an SSH session with the remote host, the shell pauses and prompts you for username and password. You provide your credentials, the server checks them, and either grants you a login shell or not. This process is interactive, and if you have multiple servers to log into, you repeat this process each time. Now with SSH keys, things improve. You create a public-private key pair and copy your public key to every server you want to use your private key with. You should only have one copy of your private key, so make sure to use a passphrase. And don't worry, we'll get to our demo very shortly. When you use your private key to SSH, you will be prompted for your passphrase every time. This really isn't much different from using a password. The way of getting around this is using the command SSH Agent. You'll start an SSH Agent process, which I'll refer to as Agent Process. Load your private key into memory, and anytime you SSH, the shell will automatically use your private key without prompting you for your passphrase. This process scales very well when you have several servers you need to log into. But there's an issue with this. The agent process we just spun up is only visible to your current bash shell. If you launch a new bash shell, which is very common, you no longer have access to the agent process you just created. So you have to repeat the steps over again for every subsequent shell. Very annoying. Keychain solves this issue. Your first login shell will call Keychain. And if an agent process is not running, Keychain will spawn one, load your private key for you, and prompt you for your passphrase. Keychain serves as a front-end to your agent process now. The magic happens whenever a new bash shell is created. Every new shell will call Keychain, but we'll see there's an agent process already running. Keychain will reuse that agent process. You won't even be asked for your passphrase, as you'll see soon. Now every new shell will have immediate access to use your private key. Without further ado, let's head over to the shell and make this happen. Here's the roadmap to implement what was covered in the previous video. First, we'll generate our SSH key pair, then transfer our public key to the respective servers. We then test our private key, then we can implement Keychain. To generate an SSH key pair, run the command SSH keygen. Here, I will choose the default location, And in my case, I didn't have the .ssh folder, so it was created for me. I'll choose the passphrase test123 for this example. Your private key is also called your identification, and your public key has a .pub extension. The rest of this information we can ignore. Now we copy our public key to our remote host with the command ssh copy ID. We specify the public key with the -i option, then provide the username and host we are sending our public key to. Here's more or less what you should see. Confirmation to continue with this connection if this is the first time talking to the remote host. The command will also check if the public key is already installed. If it's not, you will be asked for your password before installing it. And assuming everything works, it tells you your key was added and how to test it, which we'll do in the next section. First, we'll clear the screen. To test our private key, we use SSH. With the -i, we specify our private key and give username at host. And we are asked for a passphrase instead of a password. And we're in. If we exit and reconnect a few times, it will ask us for our passphrase every time. Which isn't much better than asking for a password. The way to eliminate this repetitive ask is with an agent process. We use the command ssh agent to spawn an agent process, but we use it in a particular way. You wrap up ssh agent in command substitution syntax and pass it to eval. We then load our private key with ssh add and specify the path to our private key. We give our passphrase, and we confirm it's loaded. Now we test our agent process. And if we exit and reconnect a few times, we won't get prompted for our passphrase anymore. Pretty cool if you ask me. Now here's the limitation with an agent process and how the true value of keychain becomes apparent. If I launch a new bash shell and try to reconnect, this new shell has no knowledge of my previous agent process and will again ask me for a passphrase. If I run ssh agent-l, this also tells me that my new bash shell is clueless. This is because every agent process we create is tied only to the shell from which it was created. In other words, your agent process does not persist across shell logins. So the quick fix is to repeat these steps again. And we're back in. And just to drive this point home, if we open another shell, same thing. No agent process. Rinse and repeat. First, let's make sure we have Keychain on our system. We do not, so we'll install it. And now we should have our output. If you go to the Keychain website, it has a lot more details on Keychain, including anything and everything related to public key authentication. But the main section we are interested in is this. Copy this line and paste it at the very end of your shell's login script. Your shell's login script will vary depending on your distro, but for the Ubuntu version I am using, it's .profile in my home directory. I'm going to change this to the full path of our private key for completeness and for learning purposes. Here's what happens when I launch a new login shell. Keychain will run, and if you see starting SSH agent, then we know we don't have an existing agent process. And Keychain will spawn one up for us. Then Keychain loads the private key we specified and asks us for our passphrase. Keychain is now automating the commands we ran earlier, SSH agent and SSH add. When we reconnect to our remote host, we are not asked for our passphrase. And if we exit and reconnect a few times, same thing. Now, if we launch another login shell, Keychain will see an agent process already running and will reuse that same agent process, including the key already loaded. And I can immediately use SSH. And if I launch a few more shells using the tool Tmux, I'll keep reusing the same agent process. And with some Tmux magic, I can log into the remote server from all of my new shells with no need to enter my passphrase. Here's the road we traveled to implement Keychain. We generated our key pair and transferred it. We tested our private key, then implemented Keychain. The main benefit of Keychain is having to enter your passphrase per reboot instead of per shell login. This solution scales very well when you spawn multiple shells and when you have to connect to dozens, hundreds, and even thousands of servers. Keychain can also be leveraged with Ansible, connecting with GitHub, and can also be leveraged in your local cron jobs, just to name a few. With Keychain, you will become a more effective and efficient Linux user and systems administrator. Let me know in the comments below how you plan to use Keychain. Thank you and have a great day.